So, welcome everybody to the last talk for today. So my name is still Matthias. This talk is also TLP White, and after the talk we will have surely a lot of time since it's the last talk for today for a Q&A session. So if you have any questions, please line up at the microphones. As usual, in the first step there is a possibility to rate the talk. So if you enjoyed the talk, please give the speakers feedback afterwards. If you have any devices, mobile phones, whatever that can make noises, please be so kind and turn them off. So, and it's now an easy introduction for me because the two speakers have the same name. So these are both Pawels. They are working with the Polish CERT, and the thing they are going to present you today is a central system for malware analysis. It's an open source platform. It's called MWDB. And now give them a warm round of applause and enjoy the talk.
Okay, thanks for introducing us, and thanks for all of you to coming to our talk. It's been a long day for all of us. Yeah, we came here to talk about our open source tools. Open source is kind of a key in what we are going to present because we really try to put majority of the code out there on GitHub for others to use. So we'll start with a quick introduction of kind of our kind of where we came from, why we started building the kind of tools in this particular way also. So a very quick introduction of the team. CERT.pl is a national level team, as the name suggests, for Poland. We have a pretty long history, which we'll not cover in this talk. We are also part of a research institute called NASK that does multiple things. It's also registered for .pl, but that is also the kind of a bit of a research environment that our team is located in that has some impact on how we approach things. What is important for what we do, that you could say that we are in a threat intelligence business and have been well for many years. Being a national level team means that to some degree we need to take care of various threats, various incidents that can affect either regular citizens, small enterprise, or big critical companies in Poland. Well, nowadays, as we know, phishing in terms of quantity of incidents is probably dominating the landscape. But malware was always kind of important threat, important vector in attacks, and a tool used by threat actors. It's still, like if we look at our statistics, it's the second biggest source of incidents in our constituency. And so what we want to do is to make sure that whenever there's a new malware campaign in Poland, we are able to detect this as soon as possible, ideally before actually victims get infected. Then we want to, whenever possible, to warn victims, or it might be affected institution that is targeted, especially for financial institutions, or the victims that were infected, and then if we can mitigate those campaigns either by taking down the infrastructure, supplying IOCs for companies to block things on their endpoints, and so on. If we take a look at a bit of a history, how our tooling, our automation developed, in the early days, we always had some level of automation, but it was mostly case by case. For particular malware families, we had some trackers or whatever that was suited for that particular family. And when we had some other incidents, other campaign, and it was suitable for automation, we developed some other scripts typically. However, that changed, or the environment we operate in changed a bit in, let's say, around early 2010s, so a decade ago, give or take it. I'm not being very precise here, where there is a rise of a commodity malware, especially bunkers in our case, where you could see that the malware actually can get used by people with little technical knowledge. The criminals are just buying builders on the market. They can just supply configuration that they provide, and they don't need to write malware. They just buy it off the shelf. And that means that we get campaigns that with the same family, with different configurations. So we get a lot of samples, but then we could actually, the automation made even more difference for us in terms of our ability to analyze those campaigns. In let's say around mid 2010s, we had our first kind of generic approach where there was actually our tools became capable of analyzing multiple kinds of malware, and in some consistent manner. That was a beginning of some common framework for automation on our team. A couple of years later, our maturity as a team increased, so we were able to track multiple botnets like almost real time by looking at the command and control infrastructure. Recently, in recent years, we kind of put quite a significant effort into releasing many of those tools as like a proper supported open source projects that you can also use. If we look at what the Malware Lab is, it's how we define it. It has three main roles. One is collection of data, of samples, of technical threat intelligence related to malware, IOCs, and so on. And then it should provide a way to integrate family-specific analysis tools, so specific tools that can analyze specific malware family that we can plug into some common framework, and ability to share this information, so export this information and share it with our partners, with our constituents. We are going to talk about mostly open source projects. You can find them on our GitHub. And let's start with MWDB Core, which is the core of all the things.
So, hello everyone. Okay, so we start to make a brief introduction to the projects. It will be built on the canvas of these 3 points that were shown before: collecting, analyzing, and sharing the data. So the first thing is we need to collect somewhere all of this data we want to analyze, and that's why we made MWDB Core. So the MWDB Core is kind of the central component of our laboratory design. It is meant to be a repository for organizing all the artifacts that we are working on as a malware analyst. And as we have a central point where we are collecting all of the data, we can also use that as an interface. For example, interface to our whole analysis pipeline, because all data are aggregated in a single point. We can use that to explore for some correlations and so on. So that you can look at that component as like for a database, but it should not be considered as a general malware threat information sharing system. The common question at this point is how is it alike or different from MISP? Actually, it's a completely different kind of thing because it's more focused on the malware artifacts and is kind of meant to be used by malware analysts. The main data model design is strongly focused on these artifacts, and they are divided into 3 types: files, configurations, and blobs. And the first thing that are pretty common are files, but files are meant to be the whole chain of binary data that can be used by the analyst. So from the infected archives to documents with macros, droppers, to the exact .exe files with the malware. Finally, we can also put there some memory dumps from our sandbox. And the second thing are configurations. As Paweł said before, malware is highly reused. It's bought by the criminals in a kind of generic form, so it needs to be parameterized. And we can parameterize the malware operations in 2 ways. The first way is static, where the data crucial for the operation are put in directly in the binary, like, for example, encryption keys, CNC addresses, botnet version, API version, and so on. All of these data that are somewhere contained in the binary can be extracted into a single structure that describes the malware pretty uniquely, as it was configured by the criminal, by the actor. Other type of configuration is dynamic configuration. Well, it isn't kind of configuration, it's distributable form. It's kind of representation of the data that are coming from the command and control. So, for example, if we have some peer-to-peer botnet, it can be list of peers. They can be commands, webinjects. But what is important, if it's contained in the configuration type, it means that we are able to label this data, to see their semantics, and to put them in structured form that can be useful for further automation. And usually that structure is determined by the author of malware analysis script that is extracting these configurations. So it highly depends on the malware family. There isn't any standardization. So configurations are kind of end goal for malware analysts because they contain also some consumable IRC information. So they can be used for different purposes. And usually these configurations are coming from these memory dumps because malware is usually protected by some other layer, by Packer protector. And we have some hybrid approach. Firstly, we are doing analysis in sandbox. And our sandbox is tuned to dump regions that may contain the unpacked code, the unprotected parts that may contain the parts of configuration and parts of code that are determining the semantics of this data. And if we are able to dump the unprotected code, then we are shipping all of these dumps to something called configuration extractor, which is a bunch of scripts designed to rip the configuration from currently supported malware families. The next thing are blobs. Blobs are text data, which are nice to have in repository, but we are not so good in parsing them, in making structures out of it. So, for example, if we have some decrypted strings, for example, that are protected by the malware somehow, so there is decryption routine, we can, as an early analysis, we can make a script that rips all of these decrypted, protected by malware strings into the text file, and then we can use some other approach that will choose the appropriate strings for other operations. The same for webinjects. The format for some botnets isn't very stable, and actually we have tried to parse them at some point, but it seems that very often they are more useful in its raw form. So when we are parsing something, there is a possibility that we are losing some information because, for example, we don't expect that information in the exact place. And how we are getting the dynamic information? Well, the static configuration is kind of parameters for bot execution. So if we are able to somehow re-implement the protocols and the communication, we can use these parameters to automatically gathering the dynamic information. And that's something called mtracker that was described in some previous articles and presentations. And all of these things can be connected to each other. So if we are lucky enough, we can have some nice graph representation, hierarchical graph. So we are able to find some connections. Like, for example, samples that are connected to the configuration are fetched dynamically. And for example, they can be plugins, modules, or updates that can also provide another configuration and so on. So we can have a whole malware infection chain within our repository. And also we have lots of different metadata, like tags or attributes that are describing the source of the samples or some text metadata that are related with that artifact. For example, we can have some relations to other systems, like our incident tracker. Well, that was about collecting. The second thing is about analyzing. So analyzing things was usually done in CERT.pl via a set of loosely tangled connected scripts that were used for various purposes. And that network came to be very complicated at some point. So we won't be able to quickly attach another scripts because we needed to analyze the whole network of connections before we attach something new. So we also decided to make a framework for that called Karton. And the design is based on something that we need to deal very often as malware analysts, which is Pareto rule. So if you are writing some processing script, the main effect, the most important effect, that is gathering the data from some artifacts, is pretty easy to achieve because you need to do some malware analysis and make a script. Well, but there are much more challenging things, like integrating that script so it can work on the live feed, on the live data, to make some appropriate logging, so we can debug the workings of that script after some time, if it still works for current samples. Proper error handling, so it doesn't crash silently, and so on. And we decided to make, we started to notice that these things are pretty common across these scripts. So there is a similar code base that is handling all of that stuff that is meant to integrate our script with other services. So we decided to make a small framework that will provide all of these common things out of the box. And that is highly visible in the design. So shortly, Karton is meant to be a microservice-based framework for making dynamic malware analysis pipelines. And the main design goal was to be able to quickly deploy new scripts to the system. We tried to use some ready-made approaches, but unfortunately, they didn't really, how to say that? There were not solution that was able to work in that plug-and-play manner. So we decided to make something simple based on Redis that provides the queues, the task queues, and Minio for common file storage that are needed for the time of analysis. And what I mean by talking about microservices. So microservice is meant to do the one job and do it right. So we are splitting the responsibilities across various scripts that have well-defined inputs and outputs. So the single script is attaching to the queue by defining what kind of data it wants to receive. And then it has some well-defined output, what kind of data it emits, so other scripts can also adapt to that workflow and the authors know what data to expect. So for example, we have the most basic kind of script is classifier that everything it does is the classification of file type because it isn't that obvious very often. For example, for scripts, if we use the file command, we see only ASCII text with long lines and so on. So for example, in that service, we have some heuristics that is looking for common keywords for script languages and is choosing the appropriate type. The second thing is extractor that also tries to match the common passwords for encrypted archives like infected because it's usually the easy way for distributing malware across analysts in some corporate environment. So we need to have these files encrypted to not be spotted by some antivirus solutions and so on. And that extractor just extracts the archive and is producing the tasks with the files contained in it. And as we have some actual malicious file, for example, Word document that comes from that classifier stage, based on that, that document can be consumed by some specialized scripts that are, for example, designed for extracting macros from these Word documents, or for analyzing the exact macro for specific campaigns that are using a specific dropper. For example, for Emotet, there were very common documents, and we have tried to collect all of the distribution URLs directly from these macros. And as they were very similar to each other, we decided to make a specialized scripts, especially for that purpose. And what is really important in the microservice frameworks is the inspection of the queues and the whole network of services. So Karton comes with a small dashboard, which allows to administrate the system and make an inspection about supported filters by the services. I think we will try to implement the output definitions as well at some point, but currently they are determined kind of dynamically based on the history of tasks that were emitted by service. But it's work in progress, I guess. So okay, that's about Karton. And finally, we are getting to the last point, which is sharing. Because all of these systems were made mainly for our own purpose. It was a long story of rewriting, designing, and making it able to deal with newer campaigns. And at one point, we decided to make it kind of open source. So we decided to publish the frameworks, the tools, without the modules. to make people able to design a similar malware lab using our tools. But because not all of you need to have own malware lab, and most of people in IT security are just using some services for that are ready-made, we decided to share our central system as well under the mwdb.cert.pl portal, which is I forgot the word. In general, you can use our own systems, our own analysis capabilities via that interface. So you can access samples, configurations, and lots of outputs from our analysis via this service. So there are some statistics. Also, via that MWDB, we are trying to make a small community of malware researchers. We are trying to do that from 2018, and we have over 1,000 accounts. Of course, all of you are also open for the registration. And we have extractors for 130 families, but most of them are not working because they were made at some point for some exact version, and then not all of them are maintained because the maintenance of these scripts depends on the current threats in Poland. So we are trying to make also some cooperation in that manner, but it's also some work in progress. The whole repository isn't very big. It is in the scale of VirusTotal, but it's pretty okay. We have some nice integrations, like Malware Bazaar integrated with us and is pushing all of the samples submitted to Malware Bazaar to mwdb.cert.pl as well, because we are the threat intelligence vendor for it. So Malware Bazaar also is using our service for malware classification. And yeah, about the community, we have a small Slack channel, and we are also trying to use that service to share some artifacts with community via Twitter or other channels. Okay, so that's about the main projects.
Yeah, so this is what is already available, and kind of what can you use. The mwdb.cert.pl is what you can use as without setting anything up, or you can set up your own instance of the whole pipeline. And now a bit what is coming up. That would be also demonstrate the extendability. So we are what I'll be talking about is using a plugin functionality in MWDB, which allows you to extend the the interface and the operations of the of the whole system. So this in this case we are looking. Well, we're doing some research into malware similarity analysis. It's not a new topic, however, it is some direction we would like to take to extend the existing functionality in MWDB, because currently we are mostly using Yara rules and some Python code to extract interesting parts from the memory dumps usually. So by adding a bit of the automation for comparing the similarity between samples, we can try to provide classification for families, even in situations when there are new variants that are not necessarily matching our existing Yara rules, for example. And also when we have new samples, the similarity allows to pivot. This is like the idea is not new. However, this is a new feature that has been already developed for MWDB. So very quick overview of what we have already in place. We are using a combination of dynamic and static analysis. So dynamic analysis is what was already mentioned, using sandbox to obtain memory dumps. Those memory dumps are then analyzed statically. There is a tool, API Scout by Daniel Plochman, that extracts potentially interesting Windows APIs, which form a feature vector that is then used for comparison and for classification if there is a similar malware. So this is like a multi-stage process that is implemented through Karton modules actually in the backend. The plugin functionality in MWDB allows us to extend the interface by providing here, it just provides additional tab in the results where we can visualize the API vectors. So the colorful picture is the API vector or the API QR with the bits that are highlighted corresponding to the used APIs in a particular memory dump. And provide like a pretty easy to read overview of which family is similar to which degree. The text might be a bit small here, but we have like 100% similarity match with one of the existing families in these examples. Of course, that sometimes it works, sometimes it does not, as these methods do. There is no with this fuzzy matching, there is no. Actually, it is not fuzzy matching, but this kind of approaches based on similarity. They are not guaranteed to provide meaningful results in all cases. But that's not all of it. There is also an upcoming extension to that, where we are not looking at the API as a static feature, but we are actually doing disassembly of malware samples, and especially unpacked malware samples, thanks to the sandbox functionality that we have built in. And we are able to determine what is the reuse of on a code level, looking at the functions, disassembled functions, and normalizing them to a canonical form, which is then compared across our entire data set. And that is, we already have some proof of concept integration with MWDB for that system. And I expect that we'll be able to provide this in the mwdb.cert.pl interface fairly soon. In the backend, it looks like this. So there we have like very rough interface for if someone wants to get into details. But actually, in MWDB, it will be much more user friendly also for you to interact with that. So that is kind of what is on our near-term roadmap. The API vectors are already kind of running, just not visible to the general.
Yes, they need some polishing before we can make it public.
Yeah, so still, let's say, beta testing period. But yes, that's kind of the one of the directions we are taking in kind of building additional systems for malware analysis, and then integrating results of those systems in MWDB. And I think it kind of demonstrates that it's kind of really flexible tool, and you can adjust it to whatever requirements you might have. So actually, that is all we wanted to show. So we'll end with some pointers to where you can find more information, if you're interested. Obviously, official documentation, quite a lot of effort was put into that.
Yeah.
So that's
For example, there's some user guides that will guide you from through the main points and concepts. So it's nice to look at, I guess.
there are training materials actually with tasks where you can go through various parts of MWDB, also create a Karton module and so on. So it's an evolution of a training that we did last year at first, the virtual training with MWDB, Karton, and so on. These materials, their updated versions are available for you. Also, there is the automation library that wrap around the APIs, and there's also a command line interface for interaction with MWDB. And what we did not have time to talk about today, malduck.
Yes, it's kind of Swiss knife for malware researchers that are writing scripts for configuration extraction in Python. And in addition, it has a configuration extraction framework, so it is able to run modules that are compatible with malduck format.
Yeah, so important part of our code base. That's all we had prepared for this a bit high level talk. We get some grants for part of this work. If you want to register for mwdb.cert.pl, the registration is open. There's just a vetting procedure. I know we have a backlog of those applications. So if you applied, and if you did not get a response, please ping us. We'll make sure that will get pushed through. If you have any questions, we'll be here whole week actually. But if there are any questions now, we'll be happy to answer them. Thank you.
Thank you.
Thanks a lot.